I probably shouldn't have said we were done with pads because I wanted to show you how to use Operator to make a pad that works as an instrument that you would play on the keyboard, like you would actually play the chords. So we'll do a little bit of that next. And then before we do that, I just wanted to clean up some of what we got here. I noticed that this pad plays in a minor key, and so I wanted to make some adjustments to it. And one of the things I did was I moved the pitch of that to F sharp, which is minor 2 in the key of E, and that's going to fit better. All of the notes that are in that pad are going to be in the key, so it just remains diatonic. I didn't want to put it on the C sharp because it would emphasize the minor 6 chord. If you put it above the tonic, then when you play tonic, you'll hear like the third, which is very, very low, is going to sound like an 11 or sus4. So it's these atmospheric pads are very ambiguous, harmonically speaking, and they are supposed to be very much in the background, which we're going to pull them down once we put them all together. So I'm going to click on the top one, and then click on the last one, and then right click and hit group tracks, and that's going to put all the pad tracks together in one group. I'm going to zero this one out, and we're going to listen to a little bit of what that F sharp minor pad sounds like over the E. Okay, it doesn't sound too bad, so I'm going to pull the level of the pads down altogether and close that group up. Okay, so I wanted to also introduce you to an instrument that's one of the Ableton instruments called Operator. It's an FM synthesis instrument, and it's found over here in the Instruments collection, where it says Operator. And you pull it down into a MIDI track, which, let's see, which one do I want to use? For now, I'll just drop it on the piano, electric piano track for a moment. Okay, so this is how Operator lays out, just the raw instrument. These outside parts on the left and right are referred to as the shell, and this is the display window. So if you remember back to when we first started talking about analog domain versus acoustic domain sounds and electrical domain, analog is a term for the way a certain kind of electrical signal represents the acoustic signal. And digital is a numbers way, a math way, a computer language way to represent what's happening in the electrical domain. So what we have here is we talked about the way sound waves are compression and rarefaction, so they go up in pressure, they go down in pressure in the acoustic domain, they go up in voltage, and they go down in voltage in the electric domain or the analog domain. And that's what we have here. We're seeing a sine wave that's going to be produced by the computer. So in this instrument, it's digital first, but then it uses the digital signal to create an analog signal, and then that analog signal is turned by the computer into a sound that we can hear. So the way it works is we've got these oscillators over here that are producing different kinds of waves. And right now, the levels of the second, third, and fourth oscillators are off, so we're only hearing this oscillator. This is armed, and we have the keyboard key turned on. So when I play on my computer keyboard, oh, that's it, it was just too low. I'm going to hit X to go up a couple octaves. There we go. So that is a sine wave. that means that the voltage going up and down is very smooth, and we can change that wave into a different kind of wave. We have a couple of options here. Excuse me. I just didn't want to cough in the microphone on you. So if we change from a sine wave, which has a very smooth pattern, into a sawtooth wave, which is what this saw means, we get a different timbre. Let's go to saw 64. This is the most complex sawtooth wave. It's got a lot of rough edges on it. That's still just this one oscillator. So I'll go back to the sine wave for a moment. If I turn up the level of the second oscillator, what happens is the way these oscillators are stacked currently, and we can change this later, but the way they're stacked currently, the B oscillator is modulating the A oscillator, and then that plays out through the output when they're turned on. The C oscillator modulates the B oscillator, the D oscillator modulates the C oscillator, and so on. So each of these are affecting one another. So as I turn up the level of the second oscillator, you can hear it affect the tone. And then as I add the next oscillator up, it affects it even further. So we have some timbre options there. But right now I'm just going to use one oscillator. I'm going to change it to sawtooth wave 64. And these coarse and fine controls affect the pitch of the oscillator. They're expressed in a ratio. 1 means 1 to 1, so 1 to 1 is no change in pitch. 2 is up an octave. 3 is up, 2 octaves? It's going up the harmonic series, so the first one's an octave, the second one's a fifth, and then it's the second octave. So root, octave, fifth, octave, major third. So it's just going up the partials. And then we have a fine-tuning control, and that's in degrees of 1,000 of an octave. Or well, it's 1,000 of whatever you set here, so it could be an octave, it could be a fifth, etc., etc. But if I turn up the level on both of these, and then I detune one of them, or tune up one of them, they're slightly out of tune with each other. I'm going to turn that back down. So these can all be played on every note on the keyboard once you turn this instrument on. So you can play whole chords with it. And that's the basics of how Operator works, so that you can understand the next video I'd like you to watch, which is actually presented by Will, I forget his last name, but he works with Ableton and Multitracks.com. So that's a basic intro to Operator.